Hi guys, and welcome to our presentation. We're group 12 and we'll be running a flow simulation here in the SOLIDWORKS environment. So first you're going to want to hit on SOLIDWORKS add-ins over here on the top of the ribbon, and then you're going to see the SOLIDWORKS flow simulation. Give that a click. Alright, we'll let this load. Okay, now once that opens up, you're going to want to hit the Flow Simulation tab in the ribbon and click Wizard. Now the wizard, you're going to want to give a project name should you wish. Make sure your configuration is set to current. Then you click Next. Alright, we're going to be dealing with SI units, so we'll select that. We'll go Next. Okay, in our case, we're going to be modeling flow over a plane wing, so we'll click External, and then I want you to check both these boxes under the Consider Closed Cavities section. And we'll go Next. Alright, so in our case, our default fluid is going to be air. So you're going to want to go to Gases tab, expand that, and select the predefined air as your gas. Alright, we'll hit Add. Alright, and then we'll go Next. Going to make the assumption of an adiabatic wall. Go Next. We'll specify our known parameters here, just assuming kind of standard conditions here of a plane up in the air. So we'll set our pressure Alright, 75,265 pascals. We'll do 273 Kelvin. Next, we're going to want to do 103 meters per second in the X direction. So we're assuming our plane is at a cruising altitude and just traveling in the X direction. Okay, you can see kind of this is the boundaries where we'll run our flow simulation. You're going to want to go to the left here, hit computational domain. Now we're just going to crop it just so we can be more efficient with our computational power here. Just using these arrows here, you can drag it just to fit the edges of the wing. You can just kind of eyeball it. Okay, then we'll hit OK. Alright, so now we have our defined area where we'll be running our simulations. Next, you want to go to Goals here on the left of Project. Open that up. And you're going to want to look for Force X and Force Y. Check both of those. And then we'll hit OK with the green arrow. Next, we're going to want to define our mesh. So we're going to open the mesh here, go Show Basic Mesh. Now we'll right click here and open the global mesh. And just to increase accuracy here, we're going to increase the ratio factor just so we have more meshes, more calculations. We're going to want to go to 3.4. You can see now there's more meshes along the wingspan. Okay, check that. Next, we're going to go under mesh again. We'll hide this basic mesh just for better visibility when we do our plots. Okay, now let's run this guy. This will probably take a little bit. Just under the Run tab here, make sure it's a new calculation. You're obviously going to want to run it on this computer. It does give you the option to run on multiple CPUs, but in our case we're just going to do one here. We'll hit Run. So this solver will pop up in the SolidWorks environment, and then it'll give you an idea. You can see things here like the time elapsed for the calculation. You can also see an estimate for the number of minutes remaining, total number of iterations. After that's finished, it'll give you an update. Close that window, and now we can view our results. So under our project tree here, we'll just expand that. First we're going to look at cut plots, so we'll insert one, right click. First we got to define the plane, so we have the front plane here, and we'll choose a pressure plot. So as you can see now, just along that plane we have a bunch of different pressure displays over that plane along the wing. Then we can just drag that along the profile if we want to see how pressure changes along a different plane. Okay, we'll hide that. Now we'll insert a new cut plot. Let's take velocity in this case. Again, along that front plane. Now we can get an idea of the flow velocity over the wing profile along that plane. And again, we're free to move along the profile. Alright, so we'll hide that. Next we'll look at a different kind of plot known as a surface plot. We'll select Use All Faces for this case. Now go under the contours and we'll select temperature. Okay, I'll calculate for a little bit. Now we can see the fluid temperature over the whole wing profile. And obviously hotter regions in red and cooler regions in the blue. Alright, so we'll hide that. We'll do new surface plot, or sorry, an ISO surface plot. Now we'll define which parameter we want. In this case, we'll have a look at temperature again. Temperature of fluid. We'll hit OK again. And there's our results. Okay, we'll hide that. And now we'll do a flow trajectory. So we got to select which surface we want to do. So select both faces of the wing, hit OK. We'll show arrows. Type, we'll choose temperature again, and we'll hit OK. So now we get a trajectory plot for the temperature of the fluid over the wing. Another thing we can do, expand the flow trajectory, right click, and we can play, and we can see that temperature of the fluid in real time. Alright, again, we'll hide that. We'll insert a new flow trajectory type. First we'll clear this, starting points. Now we'll open the tree inside. We'll choose right plane. We'll just reposition that a little bit away from the front of the wing here. I'm going to increase the number of points. We'll do 100. And the parameter of interest, we'll take a look at pressure. We'll hit OK. Let that calculate. Here we got now a trajectory plot of the pressures over the wing. You can also play that again, see that in real time. Again, that legend is there for your reference on the window. Another plot we can do, we can go to goal plot, select all, GG force in the X and Y. We can show, and then that gives you a table here with your average values, your minimum values, and maximum values. You can see you can also export to Excel should you need to do any calculations, but for our case, it's just good enough just to show the results. Okay, thanks again guys for your attention, and we'll now take questions.